Imagine crafting a warship so fast, tough, and streamlined they could cross the ocean and sail up rivers without using a single power tool. Now picture doing that in the 800s, armed with just an axe and pure skill. That's exactly what Viking shipbuilders pulled off. One of their smartest moves was using something called the Clinker method. It might sound technical, but it changed everything. Instead of building ships from the inside out, like most others did, they worked from the outside in. They laid long, curved wooden planks, so each one slightly overlapped the one below it, kind of like upside-down scales. These were tightly fastened with iron rivets hammered by hand. This overlapping design gave the ship strength and flexibility. They could bend with the waves instead of fighting against them. The result? A ship that moved smoothly through water instead of crashing into it. More glide, less resistance. At the time, Roman ships were made using a different approach called carval construction. They built the frame first, then added flat planks to cover it, like bones before skin. Vikings flipped that idea. They started with the outer shell and built inward, which made their ships lighter, faster, and more flexible in rough seas. Every overlapping plank reinforced the next, spreading pressure evenly across the hull. That's why Viking ships were known for their grace and speed, earning names like Sea Serpent and Wave Rider. And the real magic? They built all of this using just axes. No saws, no drills, just pure craftsmanship. Viking builders had an entire toolkit of axes, each designed for a specific job. Heavy axes handled rough work, like shaping the keel, while lighter ones were perfect for finishing details. Some axes were made to cut down trees, others to split logs, and a few were so precise they acted like modern planers. In the Oseberg ship excavation, archaeologists even found axes with long wooden handles, so well made that they could still be used today with no changes. What's even more impressive is that Vikings avoided saws on purpose. It's not that they didn't know how to make them. They just knew that sawing across the grain weakens the wood. Instead, they used a method called cleaving. By splitting logs along the natural grain using axes and wooden wedges, they created stronger, more flexible planks. This approach worked with the wood rather than against it, making the final ship both sturdy and responsive in the water. These builders didn't just work with wood. They understood it deeply. They could walk through a forest, look at a tree, and know exactly how to use it in a ship. Their favorite? Southern Scandinavian oak. It was strong, flexible, and reliable. If oak wasn't available, they turned to pine, ash, or birch, but oak was the top choice. Choosing the right tree was almost a ritual. Master builders would study the grain and shape of each tree, picking the perfect curve for the ship's ribs or the straightest parts for the planks. Even the keel, the spine of the ship, had to come from the densest part of the trunk. These experts could look at a tree and estimate exactly how many planks they'd get, and where each would go on the ship. Their knowledge even extended to how the wood would behave depending on how it was split. If a tree was thicker at the base, they'd split it from the top. If it had knots, they'd adjust their cuts to avoid waste. This wasn't just skill, it was a lifetime of experience. But it wasn't the only secret to Viking shipbuilding. They also relied on tar, and lots of it, not just for patching leaks. This was full-scale waterproofing. To meet demand, they built large-scale tar production sites in the forest, kind of like early factories. One pit could produce 50 to 80 gallons in a single batch, and they needed every drop. Building just one longship required over 600 cubic feet of wood, around 1,600 hours of labor, and about 132 gallons of tar. It was hard work, but every step was done with purpose, and the result was one of the most iconic ships in history. Tar was a must-have for Viking ships. It sealed the planks, treated the rigging, and even coated wool and sails to toughen them up against the elements. The process they used was clever and simple. They dug funnel-shaped pits in the ground, let the tar slowly drip down into a container, then scooped it out when it was ready. It was messy, gritty, and incredibly effective, perfect for making a lot of tar fast. While other societies were patching leaky roofs, Vikings were already running large-scale tar production sites in the woods and building ships that could handle just about anything the sea threw at them, with nothing but trees, fire, and skill. Now, let's talk about something most people don't think of when they picture Viking ships. The sails. You might assume they were made from something light like linen or canvas. But you'd be wrong. Many Viking sails were actually made from wool. Yep, real sheep wool. At first glance, that sounds odd. Wool is warm and breathable, not what you'd expect for catching wind. But Viking sails weren't just thick blankets. They were treated with a special mix of horse fat and ochre that made them windproof and weather-resistant. The result? Tough, flexible sails that handled the harsh North Atlantic like champs. Making one of these sails was no small task. It could take the wool of about 200 Norwegian short-tailed sheep, an old breed that came straight from wild stock. The replica of the Skjold F1 sail, for example, weighed 90 kilograms when dry and took over 7,800 hours to weave. That's more than 4 years of full-time effort for one sail. And wool wasn't the only material they used. Vikings also experimented with linen sails made from flax. But flax was a lot of work. First, the plants had to be pulled out by hand, then soaked for weeks. Then the stalks had to be cracked open, and the fibers carefully combed out using sharp tools. All of that had to happen before any weaving even began. Still, the Vikings figured it out and made smart choices based on each voyage, opting for wool or linen depending on the route, weather, and how fast they wanted to go. Axes were the stars of the Viking toolbox, but they didn't work alone. Viking builders had a whole range of specialized tools, and they knew how to use them. At the site in Mastermer, archaeologists found bow drills with spoon-shaped bits, perfect for drilling clean, splitter-free holes for rivets. They also used tools like caulking scrapers to carve out grooves for tar rope that sealed the hull tight, and smoothing planes to make the ship glide instead of drag. Even their hammer setup was thoughtful. They used 2 hammers at once. One heavier hammer acted like a mini anvil, while the lighter one did the striking. It let them drive rivets fast and clean. And to hold everything in place, they used massive wooden clamps, some nearly a meter long, to grip the ship together plank by plank during assembly. Here's where things get even more impressive. Vikings had access to adzes, those curved tools used for hollowing and shaping wood. But when researchers studied Viking ships like the Skjold F they noticed something strange. Almost no adze marks. That means Viking builders got so good with their axes, they didn't even need to switch tools. Their axe work alone was precise enough to finish the job beautifully. Viking shipbuilders work without blueprints, no sketches, no diagrams, just memory, instinct, and skill passed down through generations. A master could look at a 20-meter hull and know exactly how to shape and balance it. When modern builders created a replica of the Oseberg ship, it sank. Turns out, the error wasn't in the original design. It was in how we misread it. Laser scans later revealed the Vikings had an intuitive grasp of balance, hydrodynamics, and structural integrity. They didn't work alone, either. Shipbuilding was a team effort involving boat builders, blacksmiths, tar makers, rope spinners, and textile workers. Women played a vital role, especially in sailmaking, which could take years to complete. Viking ships stood out not because of one innovation, but because they blended many clinker planking, flexible woodwork, smart sail design into a seamless system. No engines, no electricity, just axes, iron, and inherited wisdom. And their legacy still shapes how we build ships today.